We are now working on section 6, question 26, 27, 28, and 29, and this is of 23rd of June 2018. So, following diagram represents three elements and a 400 volt three phase industrial kiln. Each element has a resistance of 17.77 ohms. So, short, no volt drop is our note, and they want us to answer certain questions. What are our questions? So, draw our triangle on 7.77 with three values coming into it. And calculations determine the minimum size three-phase copper cable that can carry the kiln load current when the elements are in delta configuration. So that's our 400 volts. And we've been told how it's going to be installed. So refer to the pages 18 and 19. First, we actually have to work out what I line is. Now we know our 400 volts, so we can calculate based on this resistance here, I equals V over R, I equals 400 over 17.77, I equals, grab our calculator, 400 divided by 17.77, and we get 22.51, but that is I phase. We then need to get I phase times by square root of 3 equals I line because it's delta, and so I line actually equals times by square root of 3 38.988, so 99 amps. Now, so we know it's 39 amps. We have got to look at pages 18 and 19 according to the notes here. That's these, if you're working to a standard, are in ASNZ 3008. These are the next pages. So, it is conductor temperature 75 degrees, ambient air 30, 30 in the air, the conductor 75, so we can use this one here, and this is 3 or 4 core, this is 3 core, and we're unenclosed touching, so that puts us in this column here, and we look at stranded, solid or flexible, doesn't really matter too much. We need to be over our 40 amps, and either way we get there with a 6 mil. Because we just follow down this list, we need a value that's bigger than 40, 33 and 32 are not big enough, 42 and 41 are, so 6 millimeter square cable. Now, going back to our previous question, we are asked calculate the total power output of the kiln when the elements are in delta configuration. So our power formula is power equals root 3 times V line times I line. It's going to have a power factor of 1 because they're resistive elements. So equals root 3 times 400 times 38.99. And equals. So I've already got that value on my calculator. So just have to go times by 400 times square root of 3. And we get 27011.817, so 82 watts. They didn't give me a kilowatt or anything, so I'm just going to go to standard base units with 2 decimal places. Next question, state the minimum current rating of the HRC fuses used to protect the final subcircuit supplying the kiln when the elements are in delta configuration. So next fuse up from 38.99 is a 40 amp fuse. Calculate the difference in the power output of the kiln if the elements were connected in star. So this one's pretty easy. We've got P delta over 3 equals P star, because star uses a third of the power of delta. So that's our 27011.82 over 3 equals P star. P star equals, and I just get my value that's already in here and go divide by 3, and I will get 900,394 watts. Now, they asked for the power difference, not the power output in star, so we actually have to get our 27011.82 minus our 9003.94, or I could just multiply this value by 2 and it would give me the same value, which equals 18007.88 watts after rounding up. Now, going with our answer sheet, we can see the first one, 38.99, 39, it's basically the same thing. And then they're saying 6 millimeter cable had a rating of 42 amps, which is why it passes. And the rating factor for 30 degrees Celsius is 1. We didn't even bother looking at that because that chart from table 13 actually tells you it's for 30 degrees, so you don't actually need to go for the fudge factors. Next one, power equals root 3 times I lane times V lane times cos theta, giving us our 27,019.2, and with the value we got 27,011.82. That is them being slightly out with a rounding error. And then we've got 18,078.87. We got 18,007.88. That is once again a rounding error on their side.